Imagine the power to disrupt entire networks in darkened cities, all from 93 million miles away. Welcome to the world of solar flares. These are not just ordinary bursts of light, but violent explosions on the sun's surface, releasing vast amounts of energy. The energy unleashed can travel through space and has the potential to impact our technology and daily life here on Earth. It's a fascinating yet daunting phenomenon that reminds us of our place in the cosmos. Now let's dive deeper and understand what exactly these solar flares are. At its core, the sun is a nuclear engine, a colossal powerhouse. It converts hydrogen into helium at its heart, releasing energy that lights up our solar system. But what about the more dramatic events it hosts, like solar flares? Let's dive into the fiery world of our star to understand these spectacular phenomena. The sun is primarily composed of hydrogen and helium enveloped in a state of plasma. This plasma isn't just a silent spectator, it plays a crucial role in the solar dynamics that lead to flares. Plasma in the sun moves in a complex dance, driven by the star's immense heat, creating currents and eddies that twist and churn the magnetic fields, threading through the sun's atmosphere. Now imagine these magnetic field lines as rubber bands stretched across the sun's surface, tangled and twisted by the movement of the plasma. As the stress on these magnetic bands increases, they can suddenly snap and realign, a process known as magnetic reconnection. This is where the magic, or rather the mayhem, begins. When these magnetic lines snap, they release an incredible amount of energy, comparable to millions of nuclear bombs exploding at the same time. This energy heats the solar atmosphere to tens of millions of degrees, catapulting electrons, ions, and atoms at high speeds into space. The result? A solar flare, a brilliant burst of radiation across the electromagnetic spectrum. These flares are not just light shows, they are powerful enough to affect entire planetary systems. The light from a solar flare can reach Earth in just 8 minutes, often followed by energetic particles that can take a day or two to arrive. The impact of these particles and the associated magnetic shocks can be profound, influencing everything from satellite operations to power grids on Earth. With such explosive energy, one can only wonder how these flares affect our blue planet. Solar flares don't just light up the sky, they send shockwaves throughout our solar system. The sun, a bustling hub of nuclear activity, occasionally throws these spectacular tantrums, hurling energetic particles across space. But how do we on Earth catch sight of these fiery outbursts? Enter the vigilant eyes of our technology. Solar observatories, both on the ground and in orbit, play a pivotal role. Instruments like the Solar Dynamics Observatory and the Parker Solar Probe extend their senses far beyond the confines of our atmosphere, capturing every minute detail of solar activity. These tools are not just passive watchers, they are finely tuned to detect the electromagnetic whispers of the sun before a flare can even fully manifest. Satellites equipped with ultraviolet and X-ray sensors provide a continuous stream of data, helping scientists predict when and where solar flares might erupt. This vigilance is crucial as the knowledge gained goes beyond mere fascination. The effects of these solar tempests stretch far beyond mere observation. It's a silent storm, yet its impact can be monumental. When solar flares erupt from the sun, they hurl energetic particles across the cosmos, and sometimes these particles collide with Earth. This encounter is far from a quiet event in terms of its consequences, though it begins unseen. Imagine the sun releasing a colossal burst of energy. This burst, known as a solar flare, travels through space at high speeds. When these charged particles reach Earth, they interact with our planet's magnetic field, creating geomagnetic storms. These storms are more than just light shows. They can disrupt the very rhythm of our daily technological symphony. One of the most immediate effects of these geomagnetic storms is on our communication networks. Satellites, vital for everything from weather forecasting to GPS navigation, can experience malfunctions. Signals get scrambled, leading to disruptions in GPS accuracy, affecting everything from your morning commute to airplane navigation. Moreover, radio communications can be severely hampered, creating a ripple effect that touches the operations of emergency services and broadcasters. But the interaction between solar flares and Earth's magnetic shield does more than just disrupt, it also dazzles. The aurora borealis, or northern lights, is a mesmerizing display of natural art. These lights are a direct result of solar particles colliding with atmospheric gases like oxygen and nitrogen, producing glowing waves of green, blue, and red across the sky. This spectacle is one of the most beautiful reminders of our planet's interaction with the sun. However, the beauty comes with a beast. In extreme cases, the surge of particles can induce electrical currents on the ground, potentially leading to widespread power outages. Such outages not only cause inconvenience, but can also pose serious risks to safety and economic stability. These interactions remind us of our planet's delicate dance with the sun. Through awe-inspiring natural displays and formidable technological challenges, each solar flare touching Earth redefines the boundaries of our relationship with the star at the center of our solar system. How do we protect our modern world from these ancient forces of nature? The answer lies not in the cosmos, but in the ingenuity of human technology and foresight. As solar flares unleash their fury, our planet's defense mechanisms spring into action, safeguarding our way of life. At the forefront of this defense are the satellites orbiting Earth. These marvels of engineering are equipped with specialized protocols to withstand the intense electromagnetic radiation from solar flares. When a flare is detected, these satellites can enter a protective mode, shielding their sensitive electronics and ensuring that the flow of communication and weather data remains uninterrupted. On the ground, the power grids that light up our cities and power our homes are also vulnerable to these cosmic disturbances. Utility companies have developed robust strategies to adjust the operations of these grids during solar storms. This includes rerouting power, adjusting voltage levels, and in extreme cases, temporarily shutting down certain components to prevent long-term damage. Perhaps the most critical layer of our planetary shield is the early warning system provided by space weather forecasts. Scientists and researchers monitor the sun's activity around the clock using advanced telescopes and satellite data. These early warnings allow for timely preventive measures, minimizing the impact of solar flares on technological systems. Collectively, these measures weave a complex tapestry of defense tailored to keep our technological infrastructure safe from solar tempests. Preparation and knowledge remain our best defense. Solar flares are more than just cosmic fireworks. They are a gateway to understanding the universe. As we delve into the grander scheme of things, it becomes clear that these spectacular solar phenomena are not just about the light and energy they emit. They are fundamental to our comprehension of stellar mechanics and broader cosmic process. Understanding solar flares involves peering into the heart of our star, the Sun, and by extension, gaining insights into the lives of other stars scattered across the galaxy. Each flare is a burst of information, radiating clues about the magnetic fields and the immense energy that stars can unleash. This is not just poetic, it's practical science. By studying these solar outbursts, scientists can refine their models of how stars evolve, behave, and eventually die. Moreover, solar activity plays a crucial role in shaping our space weather environment. This is vital knowledge, especially as humanity edges closer to becoming a spacefaring civilization. Consider the astronauts destined for Mars or the satellites orbiting Earth. Understanding solar flares is crucial for predicting space weather that could jeopardize these missions. Shielding technology, flight paths, and even the timing of space missions are all influenced by our understanding of solar flares. On a broader scale, these flares also contribute to our climate models. The sun's activity influences the Earth's long-term climate patterns, and by studying these solar events, scientists can make better predictions about climate change. It's a stellar example of how interconnected our planet is with the celestial dynamics of our sun. In essence, each observation of a solar flare not only helps in safeguarding our technology and astronauts, but also enriches our models of climate and stellar physics. This knowledge pushes the boundaries of what we know about the universe and our place within it. Each flare, while a potential disruptor, also enlightens our understanding of the cosmos. As we stand under the vast sky, the sun continues to remind us of its power. Solar flares, these magnificent bursts of energy, have captured our attention and spurred countless scientific inquiries. These flares are not just spectacular light shows, they are potent forces that interact profoundly with our planet. From disrupting communication networks by affecting the Earth's magnetic field to enhancing the beauty of the auroras at the poles, the impact of solar flares is both awe-inspiring and challenging. Yet each event provides invaluable data, helping scientists to better understand the sun's mechanics and predict future solar activities. The study of solar flares is crucial. It advances our knowledge in space weather forecasting, which is vital for protecting satellites, power grids, and astronauts from potential harm. Moreover, understanding these solar phenomena deepens our grasp of other stellar bodies in the broader universe. With every burst of solar energy, we learn, adapt, and prepare. The dance between Earth and the sun continues, spectacular and powerful.